Well, hello guys, here Mr. G with another video. This time we're going to be working with the grade 10s, a game about vectors. So get a paper, get your book, get a pencil, something to write, something to draw so you can follow me and write what I'm going to explain here. Today we're going to learn how to add vectors, but this time graphically. Last time we spoke about adding vectors algebraically, which is quite easy. You need the direction, you just add the vector, decide what direction is positive, so the vectors that are pointing on the negative or the opposite direction are negative, and so on. But this time we're going to be learning how to add vectors using a method called head to tail method in South Africa. That's the method we're going to be using, and it's quite simple. It's not difficult. Now for this method you need to be able to represent vectors graphically. And if we move back in time, the first video we made was the one that we spoke about how to represent vectors graphically. Here is the part where we explained that one, so please go back and watch the video if you didn't. Now, to add vectors graphically, we have to follow few steps. And the first one is optional. You have to draw a rough sketch of the situation. It is optional, however, it's very useful sometimes to get an idea roughly what is happening in the question. So I recommend you to do that, even though sometimes some people don't like it. But I think it is very useful to get an idea exactly roughly of what is happening. Sometimes the question could be tricky. Second, choose and scale. Now that one is a very important part here. We are going to draw vectors, and to draw vectors you need a scale. So you cannot add vectors, you cannot draw vectors if you don't have a scale. So you do need the scale. Remember, the scale is when you convert the specific vector into length, so you can use the ruler to draw that part. Second or third step, choose any of the vectors and draw it as an arrow. Obvious, all the vectors are drawn as an arrow in the correct direction and of the correct length. Remember to put an arrowhead. Okay, that is just now the step 3. In conclusion, what said, and I'm going to mark here, choose any vector. So you are going to choose any of the vectors that are involved in the question. It doesn't matter which one, any of them, and then you are going to draw that vector correctly according to the scale you chose and according to the direction. It's not difficult, guys. It's just drawing a vector and place it in a paper. Now, question at step 4. Take the next vector. Now, the next vector is any vector. So note, the next vector is any vector. The next vector, and draw it as an arrow starting from the arrowhead of the first vector. That is the most important part. You're going to start from the arrowhead of the first vector. You're not going to start at any point. You're only going to start at the arrowhead of the first vector, in other words, in the head of the vector. Continue until you have drawn each vector. So you have to follow this step over and over and be adding all the vectors that are going to be involved in the equation. The resultant, and this one is the other very important part, the resultant is the vector drawn from the tail of the first vector to the head of the last vector. And guys, this one is important. From the tail of the first vector, that is the resultant, to the head of the last. Tail of first, head of last. So let's see one example and see how do we apply these different steps that you can follow if you want. This is not an order, this is steps to follow. It's to organize your work, but you don't have to do it like 100% exactly like that. This one is a very two simple examples I have here. The first one says Johan pulls a big box to the right with a force that has a magnitude equal to 30 Newton. Tabo goes behind the box and pulls it to the left with a force that has a magnitude equal to 15 Newton. Find the resultant force using the head to tail method. So let's solve that question one real fast here. Now, in this case, I don't have a ruler. So for me, for my scale, one of these blocks will represent 1 centimeter. Okay, so that one is for us to get clarity there. Now this one, each block will represent 1 centimeter in my ruler. Remember, I I don't have a ruler here to work in this program, so I cannot do that. So I'm going to take like one of this block is 1 centimeter. So let's go to write the data for activity 1 or example 1. Okay, example 1, and I'm going to write the data in Word. Okay, data in Word, and then we're going to quickly draw. We can draw the scale roughly. It's very simple drawing. This one is not at scale. We have just a box, and then on this box we have a force that is going to be, let's go back to the question. Johan is pulls to the right with 30 newtons. So there is a force point to the right which is equal to 30 newton. This is not at scale. I'm going to call this one force 1 equal to 30 newton, and I'm not going to write to the right because the arrow, you can see that is to the right. Okay, and then there is another force to the left. We're going to go back and read. Let me just fix that line there. Let me just go and read so you can see. They say Tabo goes behind the box and pulls to the left with a magnitude of 15 newton. So F2 is to the left and is equal to 15 newton. There we go, guys. This is the sketch, and therefore we don't need to write the data because that one is in actual fact the data of the question. You know, let's move it here below the example. There we go, so we can use here and add the vectors on the right hand side. Now this, we have to take now the scale, and remember the scale can be selected by you guys. So let's select the scale, and for instance, now when you're selecting the scale, be careful. At least the teacher tell you what scale to use. When you're selecting the scale, you have to select the scale that you can see properly the drawing. The idea is to see the drawing, the addition of the vectors properly. So you wouldn't have a drawing that is, for instance, so small that you cannot see what is going on there. You have a book which is big or large enough, so make a scale that you can see properly the scale. Not too large, so take more than the book, not too small, so you can see properly the scale. So in this case, the scale is taken by me, so I'm going to say that 2 centimeters, remember 2 centimeters in my case, 2 centimeters is going to be equivalent to 10 newton. For example, I have 30 newtons here. So if I take 2 centimeters, remember also the scale, you can change it. You can take a scale if you think it's too big, you change it. If you think it's too small, you change it. So if 2 centimeters is 10 newton, then 30 newton is going to be how much, guys? You do cross product. This is quite simple, but I'm doing it because sometimes you may struggle with this one. So we have that x here is equal to 2 times 30 divided by 10. Very simple calculation, guys. And that gives me 6 centimeters. In other words, 30 newton is going to be represented 6 centimeters to the right. Okay, so that is the first one. We are going to do the same with the 15 newton because we need to know how many centimeters will 15 newton be. So 2 centimeters is going to be equal to 10 newton. Therefore, 15 newton is going to be how many centimeters? You do the same cross product there, guys. Cross product here, important. And you get that this one is equal to, x here is equal to 3 centimeters. Therefore, 15 newton will be represented with 3 centimeters. So I hope you're writing, I hope you're getting the idea. This is how to do this part of the scale. That is the first few steps. Is very, very easy. So now we already know the scale, we have everything we need, so we have to start drawing the vectors. Now, when drawing the vectors, they said here in the steps, take any vector to start with. So now you have to mark the starting point, guys. So you must start from any point in your book, but you must mark the starting point. Don't take to left or to right. Start towards more or less the center of the book, because sometimes you go too much to the right or too much to the left. And also try to do this work with a pencil. so you can erase that. So let's say we're going to start from this point. That is the starting point. That is going to be my 0 point. Okay, so I'm going to take now, and I'm going to take my ruler. Remember, the work must be done with a ruler. And I'm going to draw the 30 Newton, which is 6 centimeters to the right. So if you count, you have 1, 2, 3, 4, 5, 6 centimeters to the right. I'm doing this one, but you don't have to write that 1, 2, 3, 4, 5 up until 6. Remember, I said I don't have a ruler, so I'm going to represent it here. This is my vector, and be careful with the head. So this vector here is going to be F1. This is F1. I'm not going to write 30 Newton because it is shown there. Now, right on the head, look here what they said in this step there. Take the next vector and draw it as an arrow, starting from the arrowhead. Starting from the arrowhead of the first vector. So I am going to start from the head of this first vector draw. In other words, I'm going to start from here, right there. Okay, so I'm starting from the guys. Okay, so now I'm taking that vector and I draw it from there. In any point, I'm going to draw it below, but it doesn't really matter where you draw it. Obviously, don't go too far. It should be, in actual fact, should be on top of the first one. But it's fine. Let's draw it below just to make it look better. So starting from this point, because it is the head of the first vector, that point, I'm going to draw 3 centimeters to the left. So it is 1, 2, and 3 centimeters to the left. So here we go. This is my vector, and then there is the head of the vector. This purple color of mine represents the second force F2. I don't have to write 15 Newton because it's already there in this case. But if you want, you can write it. It doesn't really matter, 15 Newton. And then, for instance, let's say here 30 Newton. I'm not writing direction because it's shown there. And then the most important one is the resultant. Where is the resultant? The resultant is the vector drawn from the tail of the first vector. Which one is the tail of the first vector, guys? Here, this side here. Here is the tail of the first vector, right? To the head of the, where am I? To the head of the last vector. Which one is the last vector? The head of the last vector is that one there. So it is from the first vector to the last vector. So it is a vector that is going from there to there in that direction there, guys. Now what is coming the part? This coming the part of the scale once more. So we have in like 1, 2, and 3 centimeters. So we go back and go to the scale. This is easy, but we must always go to the scale. We say 2 centimeters is equal to 10 Newton. This resultant of mine is 3 centimeters. So 3 centimeters is how many Newton going to be. So it's 3 times 10 divided by 2x is going to be equal to 15 Newton. So that vector, the resultant vector, is going to be Fr is equal to 15 Newton. You go to the head, it is pointing to the right, so I am going to write to the right. And this, guys, is the end. Keep the proper writing. This is how to draw a vector using the method tail to head to find the result. And it's quite simple. I hope you understand. It's not that difficult. There is another example, but I think we can stop here. The video, I don't want to make it too long, and this one is quite simple. And then next video we can start with probably this example or even another one. I hope you understand. It's quite simple. Try to do it. I'm going to keep it there, stop the video, write the example, try to do it, and we mark next time when we start the next video or the next lesson. Thank you for watching, guys. I hope it helped. It's not difficult and it is quite important. Subscribe for the channel, thumb up. I'll see you next time. Answer this activity and we mark next time. Mr. G here.